Assalamu alaikum everyone. This is me Hania, Commerce Valley student at Rehan School on an academy budget. So this is my 12th interview with Maya. So hi Maya, how are you?
Wa alaikum assalam. I'm doing great. It's good to have you back for round three. What's the topic for today?
So today topic is what's the matter? My first question is what is matter and why it is important in our daily lives?
Basically, matter is anything that has mass and takes up space. Everything you can touch, smell, or feel, from the phone in your hand to the air you're breathing, is matter. It's important because, well, it's literally everything that makes up our physical world. Without it, there wouldn't be a here to be in.
Okay, how would you explain the concept of matter to someone who has never studied science?
I tell them to look around the room and realize that every single thing they see, the chair they're sitting in, the water in their glass, even the wind they can't see but can feel, is made of the same basic stuff. It's like the building blocks of the entire universe. If it takes up space and you can't just wish it away, it's matter.
Okay, what are the main characteristics that make something matter?
I think you might mean what makes something matter, as in, what are the characteristics of matter itself? The big ones are mass and volume. Mass is basically how much stuff is inside something, and volume is how much space that stuff takes up. It has both of those. It's officially matter.
Okay, is everything around us made of matter? And if it is, can you give some examples?
Pretty much, yeah. The air you're breathing, the water you drink, the screen you're looking at, and even you. The only things that aren't matter are things like light, heat, and sound. Those are forms of energy, not stuff.
Okay, how do scientists
I,
find matter?
I'm a little confused. Are you asking how scientists find networks of matter, like in space, or something more about computer networks? I'll make sure I'm on the right page.
I was asking, how do scientists define matter?
Got it. Thanks for clarifying. Scientists define matter as any substance that has mass and takes up space by having volume. Basically, if it's made of atoms and molecules and occupies a physical area, it fits the definition.
Okay, what are the different states of matter?
I think you mean states of matter. The ones most people know are solids, liquids, and gases. But if you want to get fancy, there's also plasma, which is like a supercharged gas.
Okay, why does matter exist in different states like solid, liquid, and gas?
It all comes down to energy and how the particles are moving. Think of it like a dance. In a solid, the particles are barely moving. They're just vibrating in place, which is why solids hold their shape. In a liquid, they have more energy and can slide around each other. And in a gas, they're basically sprinting in every direction, which is why they fill up whatever space they're in.
Okay. How does a solid different from
You're on a roll.
liquid and a gas?
Wait, are we talking about the ground we walk on and the stuff we put in cars? Because those are two very different types of matter. Soil is a complex mix of minerals, organic matter, and air, while oil is a liquid hydrocarbon. One helps things grow, and the other mostly helps things move.
I was asking, how does a solid different from a liquid and gas?
My bad. I'm clearly taking the soil thing too literally. So, the main difference is how they behave. Solids have a fixed shape and volume, they're stubborn and stay put. Liquids have a fixed volume, but they take the shape of whatever container you pour them into. Gases are the wild ones. They have no fixed shape or volume and just expand to fill any space they can find.
Okay, what happens to particles when matter changes from one state to another?
It's all about that energy shift I mentioned earlier. When you add heat, you're basically giving the particles a caffeine hit. They start moving faster and faster until they break away from each other. So a solid's vibration turns into a liquid slide, and that slide eventually turns into a gas's full on sprint. When things cool down, it's the opposite. They lose energy, slow down, and settle back into a tighter structure.
What is plasma and why it is considered the fourth state of matter?
Mm. Plasma is basically the wild cousin of gas. It's called the fourth state of matter because it's like a gas, but the particles are so energized that the electrons actually ripped away from the atoms. This makes it electrically conductive. You don't see it as much on Earth, but it's actually the most common state of matter in the universe. Stars, including our sun, and lightning are both made of plasma.
Okay, where can we find plasma in the universe?
Oh, it's actually everywhere. Like I mentioned, stars are the big ones, including our sun, but you can also find it in nebulae, which are those massive clouds of gas and dust where stars are born, and in the solar wind that streams away from the sun. It's basically the dominant stuff of the cosmos.
What is matter made of at the smallest level?
At the very bottom of the ladder, matter is made of atoms. And if you want to go even smaller, those atoms are made of protons, neutrons, and electrons. It's pretty wild to think that everything we see is just a giant puzzle made of these tiny, invisible pieces.
Okay, what role do atoms and molecules play in forming matter?
Think of atoms as the individual Lego bricks and molecules as the things you build with them. Atoms are the simplest units, but when they bond together, they form molecules, which determine what a substance actually is. For example, two hydrogen atoms and one oxygen atom bond to make a water molecule. The way these atoms arrange themselves and stick together is what gives every single thing in the universe its unique properties.
Okay. How are atoms
I mean that the
different
la-
from molecules?
I think you're asking how atoms and molecules are actually structured, right? Basically, an atom has a tiny dense center called the nucleus where the protons and neutrons hang out, and then electrons just zoom around that center in a cloud. When those atoms decide to team up and share or swap electrons, they bond together, and that's how you get a molecule. It's kind of like how a single letter is an atom, but when you put them together in a specific order, you get a word, which is the molecule.
Why do different substances have different properties if they all are made of atoms?
It's all about the ingredients and the arrangement. First, not all atoms are the same. You've got gold atoms, oxygen atoms, carbon atoms, and so on. Each one has a different number of protons, which gives it a different personality. Then the way they're bonded matters too. The same atoms can create totally different things depending on how they're linked together. It's like how flour, eggs, and sugar can become a cake or a cookie just by changing how you mix and bake them.
Okay. How does the arrangement of particles affect the properties of matter?
It basically determines how the substance behaves and feels. If the particles are packed tight and locked in place, you get something hard and sturdy, like a diamond. But if they're loosely connected and can slide around, you get something fluid, like water. Even the way they're layered can change everything, like how carbon can be a soft piece of graphite in your pencil, or a rock hard diamond, just because the particles are arranged differently.
How do we use our understanding of matter in everyday life?
It's actually behind almost everything we do. Think about cooking. You're basically just manipulating matter. When you boil water or melt butter, you're using heat to change the state of matter. Even the materials we choose for things, like using metal for a frying pan because it conducts heat well, or plastic for a handle so you don't burn your hand, comes down to understanding the properties of different types of matter. It's the foundation for basically all of engineering and medicine, too.
Okay. How does knowledge about
I'll
matter
take that as
help scientists create new materials?
you're asking how scientists create new materials, right? It's basically like being a cosmic chef. They take the known properties of atoms and molecules and experiment with different combinations, pressures, and temperatures to see if they can create something with a specific new trait, like something that's incredibly light but stronger than steel. It's a lot of trial and error, but that's how we get things like graphene or memory foam.
Okay. How is matter connected to technology and modern inventions?
It's the secret ingredient for everything. Technology is basically just us getting really good at manipulating matter to do what we want. Take your phone, for example. It only works because we found specific materials like silicon that can control the flow of electricity perfectly. From the lightweight alloys used in airplanes to the superconductors in MRI machines, every single invention is just a clever way of using the properties of matter to solve a human problem.
Okay. Can matter be created
I'm a little,
right?
wait, let me make sure I've got this. Are you asking if a skin made of metal could be created, like for a robot or something? Or maybe if metal can be made to feel like skin?
No, I was asking, can matter be created or destroyed?
Ah, the classic science question. The short answer is not really. There's this big rule in science called the law of conservation of mass, which basically says that matter can't be created or destroyed, it can only change form. So you can melt metal, rust it, or crush it into a powder, but you're not actually making new metal atoms appear out of nowhere or making them vanish into thin air. You're just rearranging the furniture, so to speak.
What happens to matter during chemical reactions?
That's where the real magic happens. In a chemical reaction, the atoms don't vanish or magically appear. They just trade partners. The bonds holding the molecules together break, and the atoms rearrange themselves into entirely new combinations. It's like taking two different Lego sets, breaking them apart, and using all the same bricks to build something completely different. You start with one set of substances and end up with something that looks and behaves totally different, but the total amount of stuff stays exactly the same.